You ever see the old movie Sunset Boulevard, which opens with William Holden face down dead in a decrepit swimming pool of a silent film star's mansion? Well, this pool is kind of like that. It's obviously green and not circulating, and the reason for that is that the pool pump went out many months ago, and getting a replacement in the time of COVID has proved to be exceedingly difficult. But we have one now, and this video is going to be about setting up the wiring and actually installing the thing, probably, I guess, a little bit. I'm not going to do much plumbing, though. We're back at my friend Larry's country estate, and you may remember this place from the video where I put in a couple of new Sunny Boy inverters for him. We didn't show the solar panels in that video, but there they are up on the roof. Those are real old units. Today you could get the same output in half the space for a fraction of the money, or a lot more output if you filled those racks up entirely. So there's that. But this action today is going to take place in this little pool house, and of course there's no light in there, so this is all going to be shot by headlight. Ordinarily I probably wouldn't make a video about a simple rewiring job, but the content monster must be fed, and since 1,000 of you now have subscribed to this nonsense, I figured I might as well shoot this. Also, I'm doing it for free for Larry, so he can't really complain if I take a long time setting up shots and recording stuff and filming it while I do the work. So there you go. Being over 1,000 subscribers has let me turn on advertising at the start of some of the early ones. I don't like ads in the middle of videos. That drives me nuts. But we've got a little revenue coming in from that. I think in the last week I've made my first $20 on YouTube ads, and that's practically $15 after taxes. So my retirement is secure. Anyway, let's go inside the pool house here and see what we're going to do. So as you come in the door, this is the first thing you see. There's an old ozone unit that I'm going to take out today because they're not using it anymore. An outlet and plug, and then this whip goes down to the old pump. This is the old pump still sitting here, and of course the whip needs a proper fitting on the end. I've been going back and forth on what kind of sheeting to use for that whip. That's liquidite non-metallic flex conduit, and they say it's corrosion resistant. They do store chlorine in here, so this is a corrosive environment. And that's what everyone around here uses, but if you look at the neck in 680, whatever it is, it doesn't mention liquidite. It just mentions rigid conduit or MC cable that's coated with corrosion resistant stuff, like they use in parking garages. So I'm probably just going to reuse this whip. It seems to be in pretty good shape, even though it's missing a fitting. If we continue around, there's a big old sand filter. There's the old heater in the corner, which isn't used, I don't think. And then there's another motor down here for the pool sweep. But where we're going to be spending our time is back in the corner there with this Intermatic panel, and kind of bringing it up to date and refreshing it for the new unit. And its claim to fame, besides being a sub panel that you can stick circuit breakers in, is that you can put these old school Intermatic mechanical timer units in here to switch loads on and off at particular times of day. Essentially, this is a clock motor that goes around every 24 hours, and these little fingers flip this switch on and off as they go by. And this one is for the pool pump, which is out of service and we're going to replace, and this one is for the pool sweep, the pool cleaner motor. So we'll probably take this one completely out of service, or move this one to this one and just leave this one dead, and have this one be just the pool sweep and this one be nothing. So that's the way it's going to go. You can see someone on the side here has hacked in a GFCI protected plug. It's protected by this breaker here. I just turned off, power's on. And then this switch here runs the underwater pool lights, which scare the crap out of me because they're old. They're 110 volts, they're underwater. Who knows how corroded they are. One of them's burnt out, so they don't really use that. We're not going to be addressing that today because it's frightening and awful. But so that's what's going on there. And this was just sawed into the side of this thing. So the new unit is 240 volts, variable speed, needs 16 amps. We have to treat it as a continuous load because it may be on for 3 hours at a time. Which means that it needs to be on a 20 amp circuit. And we're also going to be running the wires that feed the pump through conduit. And we're okay for conduit fill and derating. I've done the math. There's not only are the wires to the pool pump going through the conduit, but there's also wires for the general purpose plug that the whip comes down from in there as well. But we're okay on heat as far as that is concerned. Let me open this up here. The power is on, so got to be careful. And you can kind of get a look in here. So what we need to do is take this split unit out and put a big 20 amp plug in here. And the neck says in section 680, whatever it is that I referenced before, you need to put in, anytime you replace a pool pump, it has to be GFCI protected. So that means you need to get a big 240 volt GFCI breaker. Can you see that okay? Here, I'll bring it up. Bring it up close. Yeah, this baby, right? So that's like two $48 GFCIs together, and it should cost 80 bucks. And before the pandemic, it kind of did cost 80 bucks or so. But now, nobody has them. And this one wound up costing $150. So, but we needed to get one. So that's going to occupy this whole area here, which means then that we also need to put in a breaker, a 15 amp breaker for the pool sweep motor, which is, oh, let's see, that's a double. Did I mess that up? Uh-oh. Nope, I screwed up. This needs to be a double 15, so I'll have to get a double 15 for this. And this will run the old pool sweep motor. The reason we're not GFCI protecting the pool sweep motor is we don't have to because we're not replacing it. But the other reason is there's some talk that with the right plumbing, we can run the pool sweep off the main pool pump. So there's hope we'll be able to decommission the whole thing. So, you know, we'll see how that goes. All number 14 wire in here. Obviously, we need to run number 12 wire out to the pool pump, so that'll be a thing. And then the other thing is all of these, oops, turn that back on again. All of these circuits are everything else besides the two pumps, and that includes the general purpose outlets here. But then there's also a plug-in 15 amp hot tub on the other side of this pool house, connected also with all this connected with the general purpose outlets. And also there's a light in the bathroom dressing room next door to where I'm sitting now. So I think, see, I keep doing that. Why do I keep doing that? I think that the spa, the hot tub, because it's 110 volt 15 amp unit, should be on its own circuit by itself, because it practically uses the whole circuit. And in fact, since they had to wire a special plug for it, I'm surprised they didn't put in a 20 amp just to have a little headroom current wise, but they didn't. So I have also gone ahead and got a another 15 amp GFCI breaker just for the hot tub. So we're going to separate that, and then we won't have all these multiply landed neutrals and hot wires. I'm going to try to clean up this whole mess. I'll also be taking a wire brush and trying to clean up the bus there, because the ones that don't have breakers in them are a little corroded. Let's see, what else? I guess that's about it. Essentially, I'm going to just take the whole thing apart and put the whole thing back together and pull new wire through the conduit for the pool pump. So I'm putting Siemens Murray breakers in here. I think in here in this list they're listed as ITE breakers. It's a style of breaker. Breakers are supposed to be listed for the panel they're going into, so that, I don't know, I guess the metals on the bus match and you don't get electrolysis or whatever, I'm not sure. But I'm not worrying about that today, so don't beat me up too much in the comments. I just got various Murray Siemens breakers that are the right form factor, and I know they'll fit because they're all the same, and we're just going to go for it. So the bus in this panel board is fed with number 10 wire from a 2-pole 30 amp 240 volt breaker in the house, which is just about enough to do things. You know, half of that will go to the pump, and then the other half will go to the spa, and there's just a little left over for the other outlets and light, but that's not much of a load, or at least it's not used much. You know, so we may be going over a little bit if you plug some big drill or heater into one of the general purpose outlets, but you know, this is a long pull under the cement in the on the patio, so upgrading this to like 50 amps or something just isn't gonna happen. But the first thing I want to do before I start while the power is still on is measure this to see that we don't have a lot of voltage drop out here, because it is a long way from the house. So we can start out here, and we got 246, so voltage drop not a problem. And from this leg is Come on. Oh, that's weird. There we go, 121. This leg is 124. Okay. And then let's check to ground. 122. 123. And when the power's off, I'll make sure that the neutral bar is disconnected from the ground, the cabinet, because this is a sub panel, but it looks like it is. It's floating on top of the plastic there. Okay, so let's go into the house and turn off the power and rip this thing apart. So I came across something I wasn't expecting, although in retrospect it's probably pretty standard. So these are the regular terminals for the timer. These two are in and these two are out. These two are in and these two are out, and then the white wires are running the clock. But this timer has this extra switch here, which is listed as the auxiliary switch on the list, and that's these black wires here that go to these purple wires that go down the conduit to the pool heater and the pool sweep motor. So not only do these blue wires turn on the pump. Hold it. I'm about to say something that's not totally wrong, but isn't right either, so let's fix that. What that aux switch really is a fireman switch, and it was used on older heaters like this one to turn the heater off about 20 minutes before the pump stops so everything in the boiler can cool down, and that helps with pipe knock and whatnot. A modern heater does it with electronics, and I'll show you the wiring a little bit later in this video. Okay, you can continue. So everything's kind of cleaned out now, and you can kind of see what wires are coming up through what conduits. I'm going to leave the grounds back there because they're okay. But now hopefully we can put this back together maybe a little neater. I took a wire brush on the Dremel and buffed the bus contacts off because they had a bunch of, crusty pool house dust and corrosion on them. Not too bad, it's all just surface stuff, but hopefully we'll get a better contact on these tangs now. And surprisingly, this neutral feeder, these are the three feeders, the two, split phase legs of the 240 and then the neutral. And this was going into one of these terminals on the side instead of into the bus screw where it should go, and I'm not sure why. So I moved it, and then I tested for continuity in case this was broken or some reason. That's why they put it in here, but it seems fine. So this will be a neater thing. I might even cut that a little shorter to make it a little neater. So the next thing I want to do, this piece of Romex is a relatively recent addition. I'll show you down there. It kind of loops under that pipe, and it's not anchored well, and there's no clamp or anything on this. And that goes up to this box here where it's split into two, one to the hot tub and then one to the lights and whatever else in the bathroom next door. So I need to go into this box and bring a second piece of Romex down so I can bring both circuits in here, because if you remember, we're going to run one circuit breaker for the hot tub and one circuit breaker for everything else. So I need two wires in here, and we'll clamp that, and then I'll see if I have a plug for that as well. So welcome back. I've been recharging the camera for the last half hour, and while you were gone I did some work. First I finished breaking it. This was halfway broken out and it was a hole, so now it's 3/4, and I put a 3/4 plug in. And I also did something I've never done before. I bent the tangs down to keep them from hurting the wires in here, but still leave the pretty side of the plug out. So that's nicely sealed. And now we have two pieces of Romex coming in because I added one. So now the hot tub is separate from the bath. This is the hot tub and this is the bath. And I ran them in through an NM clamp. Of course, it's always a debate about whether, NM clamps are listed to have two pieces of Romex coming through them. And I guess if I was smarter, I would have put a clamp here as well, except I didn't have one, you know, on the truck, which means in my junk box I brought with me, because I don't have a truck. And, you know, I could have put one wire through each hole, and then it wouldn't be that problem. But as it is, these are clamped now, and they weren't even, you know, attached in any way before. There was no empty conduit bushing in this hole before. I needed to figure out which the wires up on the wall were going to the hot tub, so I put my beeper on it and used the inductive pickup outside to figure out which wire had the hot tub on it. And then this is the box up here that's been respliced and labeled, because nothing was labeled, now stuff is. And so we're about ready to close this up, except I'm going to shorten the ridiculously long screws on the cover plate for this box, because they're nuts, and it takes, you know, days to screw and unscrew it. There's no reason for them to be that long. So now, before I start wiring it together, we're about ready to do that. I want to replace these number 14 wires that go to the pump through this conduit down here with number 12 wire. So we'll use the old wire to pull the new wire, and that's what we're going to do now. So here's the conduit coming in from the panel, and the feeder wires go through this box and down the whip to the pump. And then there's another set of wires to run this general purpose outlet, which I believe code says has to be in an indoor location. I guess this is an indoor location within a certain amount of the pump. I can't remember why, so that's probably why this thing is here. Anyway, we're going to rip into this thing, and so we can get to all the wires and do a pull. I'll probably feed the wires in this way and pull them back to the box. Now this kind of has some kind of like zebra striping plastic on it, and it looks like it was molded into it. That's crazy. I've never seen anything like that. Maybe someone in the comments can tell me was this just like, you know, 70s and 80s design, or is the plastic deteriorating over time, or what? Anyway, and here's our two legs of the 110, the two blues going. I'm going to replace this with a red and a black, which I think makes more sense than these two of the same color. I'm going to go down and clip these wires off at the pump because we don't care about them. So there's room. I think I'll pull the two blue wires out and then use the green to pull the three new wires through. Except the green's kind of beat up, but should be an easy pull though. Should be okay. So here are our new red and black number 12s, which I'm going to stretch out now, tape together, and connect to the old ground to pull through the conduit. I'm going to put a shot of lubrication foam in here. I ordinarily wouldn't bother, but this fitting's a little tight. Cram this through here. There we go. And we're in. Hey, that came into the box easy. And we don't need much in here. That should do it. So yay. And that foam does really help, even on an easy pull like this. So now the grounds and neutrals are laid in, and I've organized all the hots, so we're ready to kind of start working on those. I did reorganize the grounds so that they're in the same order they come into the box, and I wound up, you know, putting all the neutrals on the neutral bar. Radical idea, instead of like picking up a neutral on any terminal that happens to be lying around on any device, that's the way it was before. So this is a lot neater. To be fair, I don't have one timer to deal with, so it's going to be less messy in the end. I have gone ahead and torqued all of these to 20 pound inches. And now we're ready to start laying in the circuit breakers. And as I said, I'm going to put the big Siemens GFCI on the top. And this is its big white wire that has to connect to the neutral bus. It's powering a circuit without a neutral, so there'll only be 2 wires going into that, and that seems to throw a lot of people. You know, a 2-pole GFCI circuit breaker seems a lot more mysterious than perhaps it should. You can run these with or without a neutral on the load terminal. All 3 wires, these 3, they all go through a current sensing loop inside, which is you know, kind of a big well, it's a current transformer. It's a metal, it's an powdered iron ring with wire all around it. So as current flows through on the load wires, it causes a magnetic field to be induced in that wire, and that comes to a voltage that some electronics in here can read. Some LM, you know, one of the LM series voltage comparators in here, and some other stuff to make it fail safe. But the idea is, if the current is going one way, like out to the load, it induces a magnetic field in one direction, and if it's coming back, it induces the magnetic field the other direction. So ultimately, you want those to cancel out and it to be 0, so that the current going out equals the current going in. Well, to 6 milliamps. This is a Class A breaker, so it blows if the difference gets above 6 amps, or 6 milliamps, sorry. And you still need to connect the white wire to the neutral bar because, for one, the test switch works by grounding to the neutral, so you want that to work. And then the other is the electronics in here take their power from 110 volts neutral. They go through a full wave rectifier to the circuit board. So anyway, so we will connect this to the neutral bus, which should be fun to try to get in here, and we will connect the 2 black and red load wires to the pump to this one. And then I do have a double 15 for the other side for the pool sweep, and then we'll go general purpose. Okay, change of plans. I was going to put this breaker here, but I'm going to have to put it over here because this little plastic tab that holds the neutral bar is in the way. It pokes up into the big butt of this huge circuit breaker. So I guess that's another reason why you should only use breakers listed for the panel you're working in, but we'll make it work. And here's the pump breaker all installed. And I hope I was clear. You can run this with or without a neutral because if there's no neutral, the current going out on one leg is going to come back on the other. And of course, that's going to reverse 60 times a second. But, you know, the currents will always cancel somewhere close to 0. And if there's some 110 loads out there as well as a 220 load, then some of the current's going to come back on the neutral wire. But the point is, the hot leg and the neutral that are going back to the transformer will be canceling out the leg that's feeding. And of course, this is always changing, you know, 60 times a second. What it's really doing is a vector addition of the currents to try to get to 0. Anyway, I hope that makes sense. Yes, you can run this with or without, but the breaker's neutral has to be tied to the neutral bar so that the electronics in here can work. Okay, now let's put in some more breakers and wire some more stuff. So it's coming along, but you know, I'm an idiot. But I do this every time I wire a panel. I put all the neutrals on the neutral bus, like we're not using GFCI breakers. Then I remember that, oh yeah, the GFCI breakers need to, you know, see the neutral. They need to sit on the neutral line. So then I have to take them all off of the neutral that I did. And I've done this more than once. Anyway, but now all the general purpose neutrals and all the general purpose hots come together right here. And in America, we can splice inside the panel. I know that's not true in some other countries. And so all the general purpose circuits, the receptacles in here, the bath, go to, and the pool lights go to this GFCI. And then the hot tub is here, and the pump is here. And we're going to put the sweep up to the timer. The other thing is Larry's asked me to cap off the furnace because they don't use it. It makes the pool too hot, if you can believe that. So we're just going to leave it disconnected for now. But it was interesting to me to find out that you have a 240 volt line that's on all the time, and then this other thing that was connected to the auxiliary switch on the timer, that's a fireman switch, is a dead man switch. So the boiler, the furnace boiler, always has, for the pool, has a always has a 240 volt power for its electronics, but it can't ignite unless this switch is closed, and that's what the aux switch was closing. So everything's all wired. What do we think? Better or just different? It's hard to get standard wire to lay neatly, but I know electrically it's better because the hot tub's on its own circuit now, and the new pump will be GFCI'd, so that's good. And I like having all the neutrals come to one point instead of having them all over the box. These are all the general purpose neutrals. I wound up putting them under a blue wire nut. I upsized when I actually counted how many I was sticking under there. Wound up using the timer on the right for the sweep again, as it always was, and this one won't do anything, just because I had an easier run of wire to get up here. And I think I've chosen some wire color codes that are a little more vernacular for residential, at least to me, so I think it's easier to understand what's going on. But again, this is largely a matter of taste. So I'm going to clean up the panel with a little acetone to take off the ink and mark it with new permanent ink. But first I'm going to go into the house and turn the power on and see how things are working. I also replaced this switch plug device because the old one was kind of rusty and been here a long time. And since I was in there, you might as well start again. And the wiring is simpler to it as well. These modern GFCI breakers are fail-safe breakers. They won't even turn on if there's no power. They actually have two current sensors in them, two current transformers. One to sense the power there and the other to sense the balance. But well, it didn't blow right away. That's good. Okay, well, let's see if we can fire up the hot tub now. Ah, now it latches. Very good. Should we do the test? Yep. Okay. So that's hot tub. This should be the light in the bathroom and all the outlets. And pool sweep, I don't know if they're using, and there's no wires on the pump, so the big fun ones aren't any good. I mean, we could turn this on and see if it starts up. Okay. Anyway, that's looking good at first glance. So let's see, pool light. Let's see about this outlet. That looks good. And let's check the hot tub plug. Oh, they used a 20 amp receptacle on a 15 amp circuit. That's clever. Let's see here. That looks good and beautiful. All right, let's see about the pool sweep motor. And yeah, that works. And this is it all put together. So I've got a 1/2 inch NPT 90 degree nipple to put on the end of this thing. And I want to see if I can get this old one off or if I have to cut it. And if I have to cut it, I'm wondering if I can cut it with tubing cutter, which I usually use a hacksaw, but I'm thinking a tubing cutter might be better. Yeah, this fitting goes in here a ways and needs to unscrew. Well, let's see. Push that back, and I'll go get some pliers. Oh, maybe I don't need pliers. Hey, yippee. Oh, it's metallic. Oh, well, that was easier than I thought it was going to be. Let's put this on. And it doesn't fit. Uh-oh. Oh, it's the wrong kind. Gee, I had the right kind too. Well, let me see what I have in the drawer. Well, no. I've got every kind of straight fitting you can imagine, but no 90s, and I really want to put a 90 on it. So we'll just have to wait till Larry actually puts the pump in to put that on. So right now I'm just going to jam my THWN down the hose here, and you know, if I have to pull it back a little bit later, I'll do that. You know, I screwed up on my lengths too because I'm a jerk, and so I'm gonna have to splice inside that box to get down this whip, which I didn't want to do either. But you know, what are you gonna do? So as I was going through that junk box looking for the fitting, I realized I might be able to MacGyver a light up on this wall above this. And as I was splicing this, I thought I better stop and see if I can get this plug out to kind of go up. Not sure I'll be able to, though. It's pretty rusted in there, so maybe this is a lost cause. Boy, don't think so. Well, it's tearing up the metal and making a hole. I might just be able to brutalize it out. There's just a ring of the plug around the top that's sort of welded to the threads, and I'm trying to, you know, bang it all to hell so I can get it out of the threads, but they're fused. So I don't know, maybe a drill. That's made it shiny. Don't want to damage the threads. Unibit was doing better. Try a smaller one. It's almost got it, and it's leaving the lower threads alone, so I'm gonna go back to the bigger Unibit. It's falling out, I think, finally. How about that? It fell out. All right, it's just pieces. So hopefully I won't have to swap out this box now for something that was essentially extra credit. Let's see if we can screw something in that or not. I have these greeny waterproof fittings. Should be good in here. Let's see. So screw in, please. Please, please, please. Oh yeah. Well, how about that? We got it. So let's see. Let's see if we can build something then. And let's see about taking this off the wall. Oh man, these are all rusty too, but it's turning. And hopefully this is kind of just a bracket. Well, no, fuck, looks like I have to come out. Shit. Oh man. It's coming. Yeah, there's two down here too. This one's in better shape. I don't know what this fancy 1970s attachment stuff is. This is just a, looks like a regular Phillips screw into the masonry. Don't use power tools because it'll just tear it up. I'm tearing it up anyway. I think the big guy might be too big, but let's see. Well, maybe. Oh yeah, duh. Well, this is the tool, man. You swine. Yay. Yay. Well, that's dust. This chlorine is really nasty stuff, boy. I see why it's a corrosive environment. It just eats everything. Even just a little bit in the air. Okay, let's see what pieces I have for this. So I'm thinking something like this, which is a piece I have, and then I'll cut off the end of this here, and that'll get us up to a good height so the box can be up near the top. And I'll spare you all the drilling and anchoring. This should probably be a weatherproof box, but oh well, what I got. So we're mounted. I should have kicked the bottom piece because the box is floating, but I did kick the top piece a little bit, kind of a crummy kick, and the top box up there is anchored with a couple of blue masonry screws, so it's pretty solid. And now we'll run some wire down the thing. So this is a scavenged box, and it has this hole, so I'm going to plug it with a knockout plug. So I'm going to do a bit of hack improvisation, put duck seal, which is kind of this modeling clay stuff, into these holes back here just to seal them up. You know, keep the bugs out. So I think I have the correct size 90-degree liquid tight connector now. Before I just looked at the bin and it said 1.5 inches, and I just saw the 1/2. I didn't even see the 1. So this is actually a 1/2. So that looks like it'll be fine. And we need to get all these goodies on here. So yes, I will pull this wire back. See if we can get it out that way, or if we're gonna have to disconnect everything and do it. Is that gonna fit over? I should have put that on first. Okay, let's see if we can actually get the wire to come back out the end now. And we're gonna have to run the fish tape or a wire up to pull it down. Doggone it. Okay. I'm hoping that this is just such a gentle and easy pull that I can just tape these wires together without actually braiding them. Famous last words, but we'll see. Yeah. Leave an end, make a friend, is that the saying? Yeah. Oh, I don't know, it's gonna be tight on the other end. Might have to stagger them. Okay, we're here. I don't know. I think it's too big. Oh, yeah. Hey. Hooray for me. So if I was a little more ambitious, I would have swapped this box out for a 4x4, but this didn't come out too bad. And I always like to pigtail to a device instead of wiring through it, because then you can remove the device and the circuit still works. So the new whip is finished and ready to go, coiled up on the floor. It's capped off and the circuit breaker's off, so it should be safe. And now we also have this, yay. So there's finally light in here. Larry swears he's going to plumb the new pump in tomorrow, and we'll see if he actually does. But in case his plumbing goes awry and springs a leak in the middle of the night, at least he has a light here now to work on things instead of just a headlamp. I went for a waterproof switch cover here, so if you're flushing this big sand filter and it splashes, it has a chance of staying dry. I'm sure this kind of porcelain burn base and bare bulb isn't allowed in kind of a storage lamp facility. This should be like a bulkhead fixture, you know, that's waterproof. But this is an LED bulb, so if you hit it, it's plastic, and it should break nicely. And if you short anything, it should throw the circuit breaker. Of course, this burn base has got holes in it where the where water can get in. I may stick some duct seal in that. Anyway, so if you're watching this ending, then this is the end of the video, because I never came back with the camera after Larry plumbed it, or he took longer to plumb it than I thought. So I shot 2 versions of this. So this is the end of this video. So thanks for watching. Like, subscribe, and we'll see you on the next one.